Okay. Um, so this next unit that we're going to study has to do with Earth history. Be kind of a short unit. This first portion of that has to do with um, more of like the geologic time scale. And this is just kind of a goofy little joke here. A couple of rock historians talking about how old rocks are, and that one's really old and that one's really super old. Um, as we know, not all rocks are old. I mean, around volcanoes and things like that, you can have rocks that are brand new. Now, the rock that they're made out of isn't brand new, but they are new rocks because they've just formed. But when we're talking about ways of figuring out how old things are, there are a couple of different ways that we can do that. And the first one, and the first system or whatever you would like to refer to it as, is called relative dating. Relative dating has nothing to do with going out with your cousins or anything like that, which probably is the best idea. Relative dating, all it is it's putting things in order. It's relationships. It's saying, if these are rock layers, saying this is older than that. There are no numbers in relative dating. It's kind of one of the big things. There's no dates, there's no numbers. If you're using relative dating, you're just saying this is older than, or that is newer than this. So no dates for relative dating. Now, if you're after a specific date, if you're after a value, if you're looking to quantify something, then you want absolute dating. So absolute dating is assigning a number. It's giving it a value. So relative dating, no numbers. Just this is older than that, or this is newer than that. Absolute dating has numbers. So today we're going to focus on relative dating. Absolute dating we'll talk about on Thursday. Moving on. All right, so some rules or laws of relative dating. First one is original horizontality. So just one second. Sorry about that. So original horizontality says that when sedimentary rocks form, or really any rocks form, they are originally horizontal. But those rock layers originally form horizontal orientation and are flat. Things might happen that that tilt those or skew those or change those over time, but to start with, they start out horizontal, they start out flat. The next one is superposition, or the law of superposition. And that just says that the new stuff is on top of the old stuff. You can think of it as if you're digging a hole, the deeper you dig, the older the stuff is that you're getting into. You kind of break down the word superposition. That prefix super just means above, or extra. So it's above whatever position. Another example would be for the 19 people that still get newspapers every day. The person gets the newspaper, in the morning, reads it, puts it down. Well, at the end of the week, there's a stack of newspapers. The newest one is on top, the oldest one's on bottom. In this diagram, these are numbered oldest to youngest. So 1 is the oldest, and then 2, 3, 4, 5. So the newest stuff is at the top. That's the superposition or law of superposition. So this, using relative dating, you could just say, layer 3 is older than layer 5. That would be relative dating. No cousins involved. The next one, cross-cutting relationships. Cross-cutting relationships, intrusions and faults that cut are young. So things like in types of intrusions like dikes or faults, so any sort of a break, those are young. Those are the newest things. The newest thing is also going to be whatever is undisturbed or not broken. So the diagram on the left, you have those 3 layers, oldest at the bottom, youngest at the top, and that dike cuts across it. That's the newest or the youngest thing because it's unbroken. It's the one that cut across the layers. Nothing has broken it or disrupted it. The one on the right, with dike A, dike B, and dike C, which one of those is the newest or the youngest? Somebody could just say it or put it in the chat or whatever. Of dike A, dike B, or dike C, which one is the youngest? Which one of those 3 is the youngest? A, B, or C? Not all at once. Overload the system. That was sarcasm. Okay. The youngest would be A. So here we have rock layers. Dike C cuts across. So, at the time the dike C formed, that was the newest thing. And dike B forms, which cuts across dike C. So it's newer than dike C, and then dike A cuts across dike B. As far as determining which one is oldest, you can think of it as kind of like layers. So which one is on top? If each feature is a layer, which one would be on top? And since dike A is unbroken or undisturbed, it's the newest, youngest thing. All right, so a little video clip. It's like 2:21 or something like that. It's pretty short, but it kind of introduces the next little section that we're going to talk about. Oops, just kidding.
Have you ever been to the Grand Canyon or seen photos of it? You probably noticed that the eroded walls of the canyon are formed of numerous layers of rock. When you look at a cliff or rock face, you might see a uniform face of rock. More often, like the Grand Canyon, the cliff will have several different layers. If 2 adjacent layers of rock are missing an interval in geological time, geologists call the surface of contact between them an unconformity. Unconformities are common in sequences of sedimentary rocks, where a much younger layer lies directly on top of an older layer. In the Grand Canyon, you can observe that the unconformity exists where a much younger layer lies on one formed much earlier. Here, the top layer is 1 billion years younger than the layer beneath it. This period of time is so significant that geologists call it the Great Unconformity. There are 3 different kinds of unconformities. An angular unconformity is formed by a process that begins when sedimentary rocks are deposited into horizontal layers. These rocks are then deformed, tilting due to forces in Earth's interior. Next, weathering erodes the tilted rocks. Finally, another episode of sedimentation deposits additional horizontal layers on top of the angled layers. Another type of unconformity is a disconformity. A disconformity results when a new layer of rock is laid down on top of the eroded surface of a much older rock. Both layers of rock are horizontal. Because the layers have the same orientation, a disconformity can be harder to recognize in the field than other types of unconformity. A disconformity may be evident only if the rocks are dated, using fossils or radioactive dating. A nonconformity arises when sedimentary rocks are deposited over igneous or metamorphic rocks. This type of formation represents significant change in the geological environment from volcanism to periods dominated by deposition sedimentation. A nonconformity is relatively easy to recognize since it is distinguished by younger sedimentary rocks above older igneous rock. Unconformities help geologists to discover episodes of volcanism, uplift, erosion, and deposition.
All right. Like I said, it just kind of introduces the next little section that we're going to go over. All right, so this first one, this unconformity. Missing layers because of erosion. So anytime there's material or layers of rock that are weathered and eroded, and then new rocks form, new layers of rocks form on top, that would be an unconformity. More specifically, an angular unconformity is formed whenever you have layers and there's some sort of folding or bending that takes place either from some force underneath that pushes it up, or compression that forces a fold. Then there's erosion, which erodes the top part of that that hill, and then you have more deposition and rock formation above that. So this forms that angular unconformity because those rock layers are at an angle, and it meets the horizontal layers of the newer rock, which can lead to some interesting and unique rock formations. So that's an angular unconformity. Disconformity, just new layers above an eroded layer. So you're getting different layers of rock, or parts of, or layers altogether can be weathered and eroded away, and then new layers are formed above that. It would be a disconformity. Then a nonconformity, a little bit different because this is involving different types of rocks as far as different families. So you could have sedimentary rock and then some sort of an igneous intrusion. That intrusion is exposed because of weathering and erosion, and then you have new rock formation above that. So that would be a non-conformity because it's two completely different types of rock. This is the one that in the little clip they said it's relatively easy to spot in the field because, again, it's sedimentary rock above igneous rock or sedimentary above metamorphic rock. So it's going to be a big difference in just how the rocks look. And then the last little one is included fragments. So anytime there are pieces of one kind of rock in another kind of rock, those pieces are older, which makes sense. I mean, the pieces have to exist in order for the other rock to form around them. So they have to be there first. They have to be older. With these two diagrams, they look very similar, but in actuality, the way that they form is completely different. And the way you can discern the two is, looking at the fragments, seeing which type of rock it is, and then you can figure out, how it was formed. So in this first one on the left, A, you have pieces of granite that are included in sandstone. So that means the granite was there first. So this granite, this top surface was exposed to the environment. The weathering and erosion took place. So there were some pieces of granite loose on the surface. And then that sandstone formed around those pieces. The other one on the right, B, here you have sandstone, here you have granite, but now we have pieces of sandstone in the granite. So with that, you already had all of these rock layers, or at least the sandstone. So that means the granite formed as an intrusion. So you had sandstone, the magma came underneath it, and then as it cooled, crystallized, hardened into granite, some of those pieces of sandstone that were right along the border between the sandstone and the granite, or the magma, some of those pieces were included in the granite once it cooled and hardened. So again, they look similar, but they're completely different in how they form. But the big takeaway is that whichever rock type is the piece, or like makes up the pieces, that's the older of the two. And then the last little thing, on that diagram, you can just circle the oldest geologic feature on the diagram. So A through K. A through K, you can just draw it onto the picture. So A through K, which one would be the oldest feature there? All right, so in this diagram, the oldest is going to be A. Because of original horizontality and law of superposition, originally those rock layers were horizontal and flat, so A would be at the bottom. And then these are in order of how they form. So A, B, C, D, E, F, and then G through K. Also on questions like this, anytime it's asking, especially this one, because everything's in order, if it's asking oldest, youngest, things like that, the answer is probably going to be one of the ends, one of the end values. So if it was, a distance or something, or an age, look at the end options versus the ones in the middle. So like I said, this one would be A. Right.